In this last section for Chapter 3, we're going to be focusing on the software that you'll see on the AP test. So a statistical software package produces similar regression output. Be sure that you can locate them. So if they give you a mini tab, out or display, when you get this, it's going to look like this. In the mini tab, this constant right here is going to be your slope. This is your y-intercept. Notice it says constant. This is S, our standard deviation of the residuals, and R squared, 66.4%. You need to know what all of these are whenever they give that to you. You need to be able to find the slope B of the line, the y-intercept A, and the values of S and R squared. So when we are given summary of fit, here's our R squared. This is a JMP file. If they're giving the root mean square error, this is the standard deviation of the residuals. And then we have our y-intercept and our slope. So these are just some different types of computer outputs that you might see. Different types of computer outputs that you might see. Using technology is often the most convenient way to find the equation of the least squares regression line. It is also possible to calculate the equation of the least squares regression line using only the means and the standard deviation of the two variables in their correlation. So to calculate the least squares regression line, if we have data on an explanatory variable x and a response variable y for n individuals, from the data, calculate the means and the standard deviation of the two variables and their correlation r. The least squares regression line is a plus bx with the slope equal to r times the standard deviation of y over the standard deviation of x. And the y-intercept a is y, the mean of y, minus b times the mean of x. This is all I have. I'm missing all mine too. So I don't know if they came through and used more. But you're welcome to have them. Doing a video. They'll love that. So correlation and regression wisdom. Correlation and regression are powerful tools for describing the relationship between two variables. When you see these tools, be aware of their eliminations. Be aware of their limitations. Jeez. The distinction between explanatory and response variables is important in regression. So when we have this P hat, or price hat, this is our information that would be given. Correlation and regression lines describe only linear relationships. That you have it correctly. So if you look at this example, miles driven is our explanatory, major outlier is our explanatory. We've got this straight line here, but then this outlier. Make sure you're labeling them correctly. And this is straight, and that you know what each of them. The correlation for this one is a pretty strong positive correlation. Notice this correlation is the same thing, but we can definitely see a curve in the graph. This correlation really strong, but that one outlier, our correlation is still the same. Same thing here. We're at the same value, but then this one dot out here makes the correlation be the same. This is the only one that really truly has an R that we can use. Notice their predicted equation is exactly the same for all of them, but it only is meaningful for graph A. Correlation and least squares regression lines are not resistance to outliers. Here's our least squares regression line for this set of data. Notice how the regression line changes if for this blue one, we took out child 18. For the red one, we took out child 19. Notice how that can change the slope of the regression line significantly. Notice how the correlation changes as well. So least squares regression lines make the sum of the squares of the vertical distance to the points as small as possible. A point that is extreme in the x direction with no other points near it pulls the line towards itself. We call such points influential. An outlier is an observation that lies outside the overall pattern of the other observations. Points that are outliers in the y direction, but not the x direction of a scatter plot have large residuals. Other outliers may not have large residuals. An observation is influential for a statistical calculation if removing it would markedly change the result of the calculation. Points that are outliers in the x direction of the scatter plot are often influential for the least squares regression line.